Okay, I wanna rip through this. I don't know how much like explanation I'm gonna do. I don't know yet, but I'm gonna try to get through this as quickly as I can. Um, they give this side x and y, capital Y, and z and little z. There we go. That's really confusing. Um, it is common with like A, B, and C, but like a lowercase a is distinguishable from an uppercase A. Like the X is not so much, the Y is not so much, the Z is not so much. They should have went with the A, B, and C, but not complaining. It's okay textbook. Well, never mind. So they give you the angle of Y. They tell you angle Y is 65 degrees. I know this is 90 degrees. So the sum of the interior angles of a triangle have to be 180 degrees. So these have to be complementing of each other, meaning they have to add up to 90 because we already have a 90. So therefore, this is going to be 25 degrees. Boom, 25 degrees. Okay, so I got 65, I got 25. Now I have to find all the sides. I just do trig values. Just pick one. This is really awkward. Which trig value am I going to pick? Wow. Oh, they give you x. Thank God. They give you x is 16. So let's figure out what y. So I'm going to say tangent of 25 degrees. And there's a lot of options here. Is 16 over y. I guess cotangent would have been better. So I get y is equal to 16 of tangent of 25 degrees as my first answer. I don't know what that calculates to. I kind of don't care. My next one, I can find z. Something, no. Do I have z? No, I do not have z. I have x, I have y, I don't have z. I guess I'll use 25 degrees again. So I'll do sine. Sine of 25 degrees is equal to 16 over z. I guess I should have used cosecant. And so z is equal to 16 over 20 sine of 25 degrees. We're done. Big X, big Y, big Z. So the angles are 25 and 65 and 90. And the sides, little x, little y, and little z. X was 16. Y is 16 over tangent of 25. And z is 16 over sine of 25. Angles solved. That took 3 minutes. That's not bad. I thought it was going to take longer. Same thing. I got my right triangle. Right triangle. Now they give us angle x to be 25 degrees. What? The same thing. Dumb. 25 degrees. Did I mess up? I don't know what I'm doing. And this is 65 degrees. Why does it seem the same? We already did that. It was the same one. It's like the complements of each other. Now they give you 8 as x. So they give you this side as x, or 8. This side we don't know, which is y, and this side we don't know. So, I mean, this is exactly the same thing. Maybe I'll use... I don't know. I can't think. So I'll do cotangent of 25 degrees. So this is going to be adjacent over opposite. So I get y is equal to 8 times cotangent of 25 degrees. This is a dumb problem. For z, I'll use cosecant. I don't know. I'm just being creative, I guess. Cosecant of 25 degrees is equal to z over 8. And so you get z is equal to 8 times cosecant of 25 degrees. This would be equivalent to 8 over sine of 25 degrees. It doesn't matter. This would be the same as 8 over tangent of 25 degrees. So I'm going to say it's solved. So big angles x, y, z are 25, 65, and 90. And sides x, y, and z, see they're smaller, lowercase. X was given as 8. It is the exact same problem. What's different? I don't know. 8. Y, I'm going to write as 8 times cotangent of 25 degrees, and z is 8 times secant of 25 degrees. Otherwise, I'm done. 5 minutes, first 2 problems are done. We gotta get to 17, so we should extrapolate. I don't know what's gonna happen. Find the values of the 6 trigonometric function. Love to, absolutely love to. All 6, why not? This is gonna be 9, this is theta, this is 12. I would go ahead and find this. No, this isn't a 3, 4, 5 right triangle. Nope. I got 144 is equal to, we'll call this a squared plus, I don't know, b squared here. B squared. 81 minus 144. I don't know. Is that 63? Let's just double check here. 81 minus 81 minus 81. Yeah, it looks like 63 is equal to b squared. So b is equal to the square root of 63. I mean, 3 definitely goes in here. I think 9 goes in there too. Yeah. 9 times 7 is 63. I hope. So this is 3 rad 7 as my length b here. 3 rad 7. And then it says find the 6 trigonometric functions. So we'll go sine theta. We'll go cosine theta. We'll go tangent theta. We'll go cosecant theta. We'll go secant theta. We'll go cotangent theta. I don't know why I do sine first. It feels like alphabetical order might be better here and do cosine first, but I don't know. I don't know why I do it in this order. Teacher yelled at me or something. I don't know. Sine is 3 rad 7 over 12, and that reduces to rad 7 over 4. It's really awkward. The next one, cosine. Cosine is 9 over 12, which reduces to 3/4. I hope. Looks good to me. Tangent is opposite over adjacent, so 3 rad 7 over 9, which is rad 7 over 3. Cosecant, there's just a reciprocal of this stuff, so we might have to do some rationalizing. So cosecant is going to be, it looks like a 4 over rad 7. Yeah, 4 over rad 7, or if I want, multiply by rad 7 over rad 7, rationalize it. You get 4 rad 7. Oh my God, 4 rad 7 over 7 looks terrible. This is 4/3. And then finally, this is 3 over rad 7. Rationalize that. That's going to be 3 rad 7 over 7. No big deal. Easy, easy. Moving on. Number 4. What? Let's see. Draw an angle measuring -80 in Sierra position. Okay. -80. Sierra position means you have the initial side on the on 0, and then the terminal side will be at 80 degrees. Not drawn to scale. This is -80. Obviously, feels like 60 or 50, but yeah, not drawn to scale. It'd be closer to the 90, I guess. Don't get mad. All right, on to the next. Rewrite each degree measure in radians and each radian measure in degrees. So convert them. So on number 5, we're going 215, and we want to change this to radians. So we're going to multiply by pi over 180. I guess you can divide by 5. 5 goes into 215 43 times. It's lovely. 5 goes into 180 36 times. That makes sense. Yeah, because you get 150 plus 30. And I believe this is in simplest form. It's a nice, pretty number. Number 6, we got -350 degrees. We're going to multiply by pi over 180 again. These cancel out. Yeah, this is 5 times 7. This is, I don't think there's a common factor. So -35 pi over 18 is my answer. On to 7. We're ripping through this, man. So 288 Whoa. That's the answer. I was cheating. It's 8 pi over 5. We're going to times by, now we want the pi's to cancel out. So we'll say 180 over pi. We want to go from radians to degrees. I mean, we already saw this. 5, it goes into 180 36 times. We already had that conversation, I believe. So this is going to be 8 times 36, which is equivalent to, how do I want to do this? 8 times 30 plus 6, that's equal to 240 plus 48, which I think is 288 as the answer. Boom. Moving on. Number 8. 8 is 9 pi over 2. Again, we want to get rid of the pi, so we're going to multiply by 180 over pi. Pi's cancel out. This is 90. 9 times 1 is 81, and we'll pick up a 0. I guess these are in degrees. Number 9 smells like arc length. What is the length of the arc below rounded to the nearest tenth? Okay, so we get 8 pi over 7 times 15. Okay, like, I'm gonna really guesstimate here. I'm gonna say this is approximately 8 times 3 because of the pi. And then I'm gonna say 7 goes into 15 approximately 2 times. So we get 8 times 3, which is 24. 24 times 2 is like, I don't know, 24 times 2 is 48. Now this is an approximation, and to be honest, it's an under approximation because this is going to be 3 and some change, and this is going to be some 2 and some change. I'm not a gambler, but if I had to gamble, I would say the answer is C with 53.9. Sounds perfect. Look at this, 10. Wow, there's nothing to do here. So it says tangent of pi. Okay, so on the unit circle, pi, we're at this point. This is -1 comma 0. Tangent is going to be y over x, and that's easy to show. Imagine here's theta, and this would be cosine theta, and this would be sine theta, and tangent is the y value over the x value. Remember, y is sine and x is cosine. So the y value is 0, the x value is -1, so tangent of pi is just 0. Number 11, it says cosine of 3 pi over 4. I mean, this just comes from the unit circle. It, at this point, should be a fact, but I can kind of show you what's going on here. 3 pi over 4 is going to be in the second quadrant. Its reference angle is going to be pi over 4. If the hypotenuse is 1, both sides have to be rad 2 over 2 and rad 2 over 2, but this base has to be negative because it's in the second quadrant. We're looking for cosine. Cosine is going to be the adjacent over the hypotenuse, so we're going to have a negative rad 2 over 2. Perfect. Going on to 12. Dude, I'm ripping through this. Maybe going too quickly. Don't know. The terminal side of theta in standard position contains each point. Find the exact value of the 6 trigonometric functions. Not fun. Not fun. When it's on the, well, when it's on the x and y axis, it's super clunky. I almost want to do 13 first, but I'm going to go with this. All right, so here's 0. 0, -5 is down here. 0. Okay, I tried this once and it was like a failed attempt. But basically, like, you have a right triangle, right? You have a right triangle, essentially. You have a right triangle. So here's my right triangle. And this seems really awkward, right? And technically, we could draw it in the third quadrant. It doesn't matter, third or fourth quadrant be the same. It's just that the base is 0, right? Like it's all the way over. But the height here is -5. So it turns out if you do a squared plus b squared is c squared. This is where this hypotenuse is going to be -5. And to be honest, this is where like SOHCAHTOA kind of fails. Like it doesn't make sense. Like we're talking about trigonometric function is a ratio of a right triangle, but we don't really have a right triangle because there's no base. But I'm drawing this fictitiously. Anyways, I'm gonna. Oh, and this should have been just 5. Well, a squared plus b squared c squared. All right, and then I'm gonna come up with all the answers here. So I'll say sine of theta. So sine is, if this was theta, this would be opposite over hypotenuse, which is -1. And then we have cosine of theta. Well, that's just going to be adjacent over hypotenuse, which is just 0. And then we have tangent theta. Be careful. This is going to be opposite over adjacent, which we can't do. Let's see, cosecant theta. This is going to be this flipped, so it's still -1. Secant theta is going to be this flipped. It's a reciprocal of that, so it does not exist. And then finally, cotangent theta. Let's go back to the triangle. So tangent is opposite over adjacent. So tangent is adjacent over opposite, so this should be 0. Anyways, I don't like it. Yeah, it's like where the unit circle really helps. Now you're thinking like, well, it's not 1 unit. The hypotenuse is not 1 unit, you know? Well, you just divide by 5 and you make it 1 unit. Like basically divide all sides, I guess, by 5. I don't know. Really clunky. It's not consistent. I think that's why I like the unit circles a lot better. All right, 6, 8. Okay, so I'm gonna 6, 8 is up here. That seems relatively easy. You know, draw this 6, 8. There's theta. This is 6. This is 8. I believe this is a 3, 4, 5 right triangle. I hope this is 10. Let's see, 64 plus 36 is 100, so it is 10. And then we find all our trigonometric functions. So sine theta is 8 over 10, or if I want 4/5. Cosine theta is 6 over 10, or if I want 3/5. Tangent theta is 8 over 6, or 4/3. Cosecant theta is 5/4. Secant theta is 5/3. And then cotangent theta, I can't even remember my writing at this point. 3/4 maybe. I think that's a 4/3. Easy enough. Dude, I'm really ripping through this. It's not bad at all. I feel like we're gonna have a lot of success on this test. I hope. Well, it's okay if we don't. Multiple choice. Suppose theta is an angle in standard position with cosine theta greater than 1, greater than 0. That is. So what does that tell us? Well, if cosine is positive, we're in the first or fourth quadrant. X value has to be positive. And which quadrant does the terminal side lie on? Oh, D, whatever. So yeah, I mean, it's the X value. X is positive in the first and fourth quadrant. Not much of a question, but whatever. Multi-part, look at that. I like multi-part. The angle of elevation of a ramp is 11 degrees. The length of the ramp is 14 meters. Okay. So let's just draw it. So we've got a ramp. And here's 90 degrees. This is 11 degrees angle of elevation. The length of the ramp is 14 meters. Which of the following expression gives the height of the top of the ramp from the ground? So we want the height. Which trigonometric function do I want to use? This feels very sine-ish to me. Okay, I like this. So if I solved it with sine, you know, which I think is going to be correct. Sine of 11 degrees is opposite over hypotenuse, so therefore h is equal to 14 times sine of 11. Never mind, that's the answer. 16, or I guess this is part A. Part B, same picture. Now it says which of the following expression gives the distance on the ground of the ramp. Sorry. I mean, that'd be cool if this was like a test question. There's like 2 problems of a test question. You're like, yes. All right, so which trigonometric function is this? For x, then we're going to use cosine. So we're going to say cosine of 11 degrees is equal to x over 14. So x is equal to 14 times cosine of 11 degrees. So I'm guessing B, and B is the correct answer. Hey, dude, this is a pretty good homework. Good 20 minutes. Well, let's see what these look like. If both angles are in standard position, which of the following pairs are coterminals? Choose all. Okay, so A is 180 degrees and pi over 2. Now, pi over 2 is equivalent to 180 degrees is over here. Pi over 2 is there. No. That was A. B, I don't want to go through all these. 150 degrees and 5 pi over 6. Interesting. They're both in the second quadrant. And I think we have a winner here. Because 150 degrees, you do have a 30-degree angle. And our pi over 6 in the first quadrant is also 30-degree angles. So it's really like, what's the pi over 6 in the second quadrant? If this was pi, I would subtract off a pi over 6, and I would indeed get 5 pi over 6. So I'm going to say B is a yes. C, don't know. 210 and 3 pi over 2. No. 2 tens in the third quadrant, and 3 pi over 2 is here. So no. Part D, 240, and this smells like it. 4 pi over 3. Okay, so 4 pi over 3 is a 60-degree angle in the third quadrant. So let's make sure. So if I do 180 plus 60 here, do I get, yep, I do get 240. Or if I add pi over 3 to pi, I do get 4 pi over 3. So this is a yes. All right, so E, no. E's a no. 60 degrees is in the first quadrant. 2 pi over 3, even though that's a 60-degree angle, it's in the second quadrant. So no. This isn't very interesting. Let's see. 315 and negative pi over 4. Okay, now this one's a little bit interesting. All right, so 315, I think I'm over here where this reference angle is 45 degrees. So 360 minus 315, it's 45 degrees. But 45 degrees is a pi over 4. So we're going backwards. We're doing the minus pi over 4. And you do end up at 315. So in this way, it is coterminal. End up in the same spot. Which of the following angles of cosine, value of negative rad 2 over 2? Well, there's two places where cosine's negative. It's both the second and third quadrant. And the negative rad 2 over 2, I mean, that's just the 45-degree angle. So I need the 45-degree angle in the second quadrant. If this is pi, we would subtract off a pi over 4. So this would be like 4 pi over 4. Subtract off pi over 4. This would be 3 pi over 4. And this one would be 5 pi over 4. So, oops, in degrees. Awkward. I'm going to say 135. I believe 135 is in the second quadrant. 180 minus 45 is 135. Yeah, it's not 180. It's not in the first quadrant. It has to be negative. 315, it is a 45-degree, but cosine's positive in the fourth quadrant. Anyways, 23 minutes. That was easy. Cake. Is okay.